Hello folks, welcome back to my YouTube channel, and we are in the Python for data science module. Our today's topic of discussion is data selection and indexing. In this video, we will discuss how can we select columns from a particular data set, or maybe it may be a single column, it may be multiple columns. Then we will have a look at what is implicit index, what is explicit index, and using that how we can select specific rows from a particular data set. And then we will also see how we can select data based on conditions. So let's jump in. You would see here the first statement is import pandas and import numpy. So this is quite familiar to you. Now it's been like we are 4 to 5 videos um, old in exploring Python libraries. So this is something that is familiar to you. Then I have uh, imported the dataset movies with the read underscore CSV function, or you may use some other function. If it is a XLS file, it will be read underscore Excel function. Then I would just like to have a look at the existing data. That's the reason I am using df.head. Oh, my bad. Here, to run this cells, df.head. Now you would see this data consists of movie ID, budget, then popularity, revenue, title, vote average, vote count, and all these things, like director ID, year, month, and day. Okay. So we had a glimpse of what is there in data. Suppose I want to have a look at only one column, or I want to select only one column from this particular data. What would I do? I would simply enter the column name inside um, inside the existing data, and I would select it with this syntax. I would simply write df, then square braces. Inside that, I will write the column name. And if I run this, you would see only one column will be displayed. Okay, this is the output that you get. If I want to select multiple columns, same thing I will do, but this time I will have to specify whichever columns I need. I would have to specify their name. All right, so I needed title and vote average, so I mentioned their name in a list. The syntax is the same. Instead of single column name, this time what we have done, we have entered a list of number of columns. Like we want to select two, you specify their names, and the data will be displayed. All right, now there is something called as implicit and explicit index in in pandas. All right, so let's see what is implicit and what is explicit. Now implicit index is represented by iloc, and explicit index is represented by loc. Explicit index is an index which you can see here when you get the output. If you have noticed, this number here, this is not a part of table. All right, this is something called as explicit index, because as I mentioned, you can see this, right? It starts from 0 and it goes all the way till 1464. Okay, you would see here as well. So whenever you try to see a particular data set, data in a particular data set, then you would see there is one additional column, you may say, which doesn't have name here, and that is nothing but an index. Okay, this is not a part of our existing data. Okay, this is not a serial number, or I have not forgotten any column name over here. It gets generated, and we can see that, and that is nothing but called as an index. But it is an explicit index, because I just mentioned that explicit indexes are those indexes which you can see over here. And what is implicit indexes, which you cannot see but they are there, they are getting generated in the background. We will see what it is when we have a look at the example. All right, so if I do df.iloc of 1, let's see what is the output. You get an output of the you get an output as a second row, because you mentioned df of 1. 1 is at where? Here. The 1 means the index, right? So the data corresponding to the index 1 is displayed. Now this is iloc, and when I do df of loc, df.loc1, which is explicit, this again shows the same data. All right, then you would wonder, hey Vishal, these both are showing us same data, then what's the difference? Yes, of course there is a difference. That's the reason we are studying this. All right, suppose I want index to start from range 1 and not from 0. By default it started from 0, explicit index starts with 0 and even implicit index starts with 0. That's why we got these similar outputs. However, we can change explicit index range and we can start it from wherever we want it to. Now suppose I want the index to be started from 1, so I have used this range function, and using it inside list function, I have modified the index. I want the start to start it from 1, so this is what I did. I gave 1 and the range till where df dot shape of 0 plus 1. You would say, what is this df dot shape 0 plus 1? So it is nothing. Let's explore df dot shape first. So df dot shape gives you what? Shape is 1465 and 11. And what I have done, shape of 0. Shape of 0 in the sense this number 1465. So if I do, oh hold on, mistake, and I just click this, yeah, df of shape of 0, if I do over here, okay, you would get 1465. All right, and plus 1 is 1466. Okay, so my range should go till from 1 to 1466. Only then I would be able to get 1465 rows. You remember the range function from the for loop that we discussed. We had discussed range function when we studied for loop. All right, so that's how it works. The range will be from 1 to 1466, wherein 1466 will get ignored and you will get all the 1465 rows. All right, so to proceed ahead, now if you look at this, the index started from 1 because we wanted the index to start from 1 and not from 0. So that's an advantage of explicit index. It will take the range from the one you want it to be. Okay, so now if I do df.loc of 1, look at this, it will give me first row, not the second one as we used to get earlier, because the index has changed, and at the first row these are the details, and those details will be shown to me. However, if I am still using iloc, right, let's see what I'm getting. This is implicit index. It still returns me 2 because we cannot change. Implicit is this index, we cannot change. All right, it behaves the way you can relate it with the Python indexing similar way, whatever we have studied earlier while we did string slicing, while we did list slicing. So at that time we had studied positive indexing and negative indexing. It is that index, all right. So which whatever is the default behavior, by default which index operate, that is the same index referred by iloc over here. All right, you would see it did not change. Now if I do it df.iloc of -1, okay, now you would quickly answer, Vishal. It will give us the last row of data because you are already aware what is negative indexing. Okay, after that df.loc of -1. Let's see what this gives me as an output. And yeah, this gives me an error, key error -1. Why do you think would this have happened? If you look at this carefully, df.loc of -1 right now in the LOC or in explicit indexes, what I have is a range from 1 to 1465. All right, and these are explicit indexes. So whatever range I had already mentioned, whatever range I want, I would be specifying there, right? So I have a range from 1 to 1465, and I'm trying to give -1 in LOC. So there is no -1 in in this explicit index range. It is from 1 to 1465. Had I mentioned -1, then this would not give me an error. Look at this. It is giving me a key error. It's saying key error -1. Um, we don't have this key. We don't know what this key you are talking about. So negative indexing and positive indexing will apply only in terms of uh, iloc. I mean both will apply only in terms of iloc. Explicit index, that is LOC, it will not apply because that is something that we have given. The range, whatever item or whatever row you are trying to reference should be from that same range. That's the reason we get an error here when we give something that is not there in 1 to 1465. All right. Now, if you want to see a particular index, then you can see that index as well. All right. Now let's have a look at row selection using implicit and explicit indexing. Here you would see df dot LOC 1 colon 10. Alright. So iloc1 means which row of using explicit index, it will be second row. Second row, why second row? Because um, I'm talking in terms of explicit index. Why I'm trying to explain this is because, see, the data, these indexes are explicit indexes. What I'm saying, iloc of 1 is equivalent to explicit index 2, whatever is there in explicit index 2. iloc of 0 will be equivalent to explicit index 1, because we have changed the order of explicit index and it now starts from 1, right? And that's why it started here from 2 and it went all the way to 10. Okay, now if I would have written 0 over here, look at this, now it will return me the first row. Look at this. It returned me from the first to the 10th. All right. So this is what we should be able to actually notice. And if you see 0 to 10 is 11, right? If we count, but it follows the range concept here as well, and it returns you how many rows? It returns you rows from 1 to 10. That is, number of rows written here are 10, not 11, because the 10th one is excluded. This is very much the same when we did slicing um, in strings or list. All right. So I always keep on referring to our older concepts, because you will be able to correlate very easily. All right. Then df.loc of 1 to 10. Now if the same thing I want to do it for loc from 1 to 10, then what's the result? Look at this. It starts with 1. Now we are telling the interpreter that okay, use loc, right? So loc, I said, will follow whatever range we have specified. We have specified 1 to 10. In this case, it will show all 10 rows. Now it doesn't ignore this 10, and it doesn't show only 9 rows. In this case, in case of loc, it shows all the rows whatever you mention over here. So these are few key things that you should remember while you explore explicit index and implicit index. The way iloc and loc works is totally different. In loc, you can change the range of the index. That is, it did not necessarily start from 0. You can mention whatever range you want, and the way it works is this: whatever you specify in the range, it will take all the rows. It will not ignore the uh, upper limit range. And in iloc, it will always give always retrieve one row less than what you have specified, because it is similar to the to our range function. All right. Now if the same thing, if you want some specific rows, you have to mention those row numbers, or not the row numbers, you have to mention the row indexes. And this is what we have done here. Df is equal to iloc 1, 12 and 18. You would see 1, that is the output that will be replied by this first element in the list is this row, that is the second explicit index row, then the 13th explicit index row, because you have mentioned 12, it will always be one more in terms of explicit index. Guys, again I'm saying, don't get confused. Explicit index, you can see, that's the reason you see this 2, 13 and 19. Implicit index you cannot see here on the screen, but we can um, definitely correlate how these things are working. It doesn't show you the exact first row details because you haven't put 0 over here. Implicit index will always start from 0. It will have negative indexing as well, wherein explicit index doesn't follow any thing kind of negative indexing as such by default. If and only if you mention some negative range in um, explicit index, only then it will follow. All right. Then df.loc 1 comma 12 comma 18, then exact same rows will be retrieved. See 1, 12 and 18. All right. Now let's move on to the next section, that is condition selection and filtering. All right. So based on condition also we can select particular number of rows or specific set of data. Here I wanted to have a look at movies which have vote average, or you can say which have rating more than 6. All right. So what I have used here, I have use the comparison operator greater than and try to do the same. However, if you notice, we get an output as a Boolean array. The output is true and false. It doesn't give me the actual data. Now, if I want actual data, what I will do, I will apply this Boolean array on as a mask on my original data. So my original data is df, and I simply put this boolean array on the original data, and this will actually retrieve the values. So wherever it is true values or those rows will be retained, and wherever it is false, it will not show up here. That's why you see there are 977 such rows which have rating greater than 6. So if someone asks me that which are the movies that are greater than that have greater rating than 6, then I would simply use this. But no, kindly note here that the output that you get by comparing it with whatever number you decide, whatever rating you decide, was boolean. It gave you true and false output. Now to we are not interested to see what all data is true and false. We just want to filter out, or we want to select whichever movies have rating greater than 6, and that's the reason we applied that mask on our data set. This is also called as a fancy indexing, sometimes also called as masking. So these are various different terms that are used for the very same purpose. Now, if you want to do a mean of particular thing, I mean, let's take the same rating column, or you can say vote average column. And I'm saying it as rating because vote average here shows the rating of a particular movie. So if I want to take an average, what I will do, I will first select that vote average column. I will take it out and store it in a different variable, and then I would take a mean of that. So here I just have done the same. To get this, I get the vote average. I just selected the column. You know how to select columns. If I want to take a mean, I can always take a mean of that. All right. So here I have got the mean. So that's all about data selection and indexing.